Preparing for a test. The class is given a list of 8 study problems from which 5 will be a part of the upcoming exam. The student knows how to solve 6 of the problems. Find the probability that the student will answer all 5 questions, exactly 4 questions, or at least 4 questions on the exam. So let's start talking about probability yet again. All right, so for our first scenario, let's consider first that we need to find the number of desired outcomes for the numerator and then the total number of outcomes for the denominator. All right, let's think about this. I'm going to have a ginormous fraction, and on the bottom, to find the total number of outcomes, that would be the easiest one. There's 8 total questions to choose from, and the test is 5 questions. So the teacher is choosing 5 out of those 8. And the order of it doesn't matter, the order of the questions that she chooses, because, if she chooses 5, 1 through 5 out of the 8, it doesn't matter if the 4th one is first and the 5th one is second. It doesn't matter. It's the same test, right? So here, it's very important to note that the order doesn't matter. When order doesn't matter, we're using a combination. Now, if order does matter, we're going to use a permutation. We use permutations and combinations to find the total number of outcomes when we're doing probabilities. So the bottom is 8 choose 5. Now the top, it says, is what we want. So let's look at A again. It says all 5 of the questions on the exam he knows. So that means 5 are chosen from the 6 that he knows, right? So that would be the total that he knows, and he's choosing 5 of them. All right, so let's simplify these bad mamma jammas. On the denominator, we have 8 factorial. On the bottom, we get 8 minus 5, so it would be 3 factorial, and then times 5 factorial. On the top, we have 6 factorial divided by 1 factorial, and then 5 factorial. I got 1 from going 6 minus 5. Okay, so the numerator simplifies really nicely. We don't care about 1 factorial because you're just 1. But 5 factorial cancels out with the 6 factorial, and we're left over with the 6 up top. How did that happen, you may ask? Well, 6 factorial is 6 times 5 times 4 times 3 times 2, blah, 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 right? Okay, but instead of going on, I'll just say 5 factorial, and that 5 factorial cancels out with that factorial. So we have 6 up top, all by hidden lump sum. And on the bottom, we get to cancel out this 5 factorial with the 5 factorial out of this, which means 8 times 7 times 6 is left. And I get to cancel out the 3 factorial with the 6 because 3 factorial is 3 times 2 times 1, which is 6, so I get to cancel that out. On the bottom, we're left with 8 times 7. On the top, we have 6 divided by... Oh, we can simplify. Let's simplify. We got everything in factors, so it's prettier. So we divide that by 2, divide this by 2. So on the top, we have 3 over 28. We're done. We're done with that one. The probability of him getting all of them right, all 5 questions right, is 3 out of 28. And actually, that's not interesting enough. I like, percents. So this would be, not a good percent. It's a percentage. It's 10.7% chance that he gets all those. Ooh, that's not a good chance. I know you guys can all relate to that. You're like, I'm not floating that, man. I'm going to study some more. So let's say the next one, it says exactly 4. Okay, so we know the total number possible stays the same. So it's still 8 choose 5. And then on the top, we got exactly 4. So think about this. Out of the 6 he knows, 4 he knows. And then how many more can be chosen out of that? Let's see. So out of the 6 he knows, he doesn't know 2 of them. Is that right? There's 8 total. Yeah, he doesn't know 2 of them, and 1 of those would be chosen. Now, that's kind of weird, huh? Now, the 6 plus 2 should be the total number of problems that can be chosen, and the 4 and the 1 added together should be the total number that are being chosen. Okay, so lots of simplifying to do. On the bottom, I already did a bunch of that simplifying, and so I can just say 8 times 7. On the top, we're going to have 6 factorial over 2 factorial, 4 factorial, times 2 factorial over 1 factorial, which is just 2. Okay, that's not incredibly difficult. All right, so this is just going to be 2. It looks all fancy, but doesn't need to be. On the bottom, we have 8 times 7. We have 2 chilling right there. All right, this 6 factorial is going to be 6 times 5 because the 4 factorial canceled out the rest of it. And then the 2 factorial is going to make this 6 and 2 at 3. So you have 3 times 5 times 2. Let's do a little more simplification. All right, so now we have 4 times 7 on the bottom, which we know is 28. Nothing else I can simplify, right? Yeah, so we have 15 over 28, and that is our answer. What are the chances of this one? I want the percent again. So 15 divided by 28, what do I get? I get 53.6%. 53.6%, because that's just interesting. Okay, so 53.6 chance that he gets that. Wow, you can find the probability of what you would get on an exam, but you would have to know what all the questions are, okay? At least 4 of the questions on the exam. At least 4. At least 4. Not exactly 4, at least 4. So that would be getting 5 or getting 4, right? Right? So we just have to take these two dudes and add them together. Because so we have this probability, 3 over 28, and we're going to add to that 15 over 28. Hey, the denominators are the same. That's so convenient. We get 18 over 28, which is our answer. But I want a percent just because I'm interested. 18 divided by 28, not 25. Dumb calculator. User error. 64%. 64.3% is the chance that he would get at least 4 correct. That's kind of weird, huh? That I had to add those. That's because we have to count both of these scenarios happening. If you're getting at least 4, then that means you can get exactly 4 or you can get more than 4. All right. And I like the problem. The problem kind of built up to that, so it saved us some work.